Now we are going to see about a ventilation system in an HVAC industry. What is a ventilation system? What is its importance? Where its application is very important, and types. Suppose if we take an normal house and how the ventilation system is very important in a typical house system. You can see here in a ventilation system here, I can say you this is an hall area, so the air is supplying, the orange color shows the supplying of air to the hall as well as air to the bedroom is also going, as well as another bedroom air is coming in, coming in, and from where and all the toilet exhaust as well as the kitchen area and another toilet, from these areas the air is trying to go out. So air is going out in a yellow mark and blue color is in, the blue color is joining with the orange. So these are inlets, and red one is exhaust. So how we are going to calculate and how important is the ventilation system in this particular house, and we are going to see uh, different types of ventilations not only for house and various ventilation systems available in the world, and how we can try to understand it. So coming to the ventilation systems, ANSI ASHRAE standards of standard 62.1 and 2022 ventilation and acceptable indoor air quality. This is the standards of ventilations we are using and we are applying actually. So please guys, please try to understand these standards, because some of the interviews also they may ask about the question what standards are being used when you are designing some ventilation systems for your house or a factory or any other uh, process areas. So you can say that the ASHRAE standard is 62.1 and 2022 the ventilation unacceptable indoor air quality. So this is the term, you can say that. So this is the standard, try to remember it. So going forward, you can see some of the very good terminologies such as CFM. What is a CFM? That is cubic feet per minute of air passing through a point. Okay, so it is a measurement of airflow. Suppose if you take a house of 1 by 1 by 1 feet, so the air which is accommodated in 1 by 1 air, so that is the volume of air, and if you measure at a single point the passage of air in 1 minute, that is called an cubic feet per minute. So that is cubic feet amount of air is passing in 1 minute. So that is called airflow volume measurement in that particular area. So example, you can see if an air compressor is outputting an 30 CFM air, means that is 30 cubic feet per minute of air that is flowing per minute. 30 cubic feet of air is flowing per minute, that is called CFM, cubic feet per minute of air passing through a single point. So if you take a house 1 by 1 by 1 and you can measure, that is the amount of air which is present, and if you calculate the flow of air within that one with the measuring a stationary point, you can find uh, how much cubic feet per minute of air is passing through the single point. So another one you can say ACH, that is number of changes of air per hour, air changes per hour, ACH. So ACH or AC, air changes per hour, is equal to 60 Q by volume. So ACPH is equal to 60 Q by volume. This is an important formula to find air changes inside a room. So air changes also we can define that if you take a toilet exhaust or kitchen exhaust, the air changes will vary according to the different applications. So why air changes has to be varied? Because number of times the air has to be replaced within an hour, that is 16 times, 10 times or 5 times or 4 times. So that is called air changes per hour. So Q is volume of air in CFM. I already told what is CFM, and volume is equal to length into breadth in the height of the space in cubic feet. So the formula is ACPH is equal to 60Q by volume. See here guys, in this diagram also, so outside temperature is very in minus, I can say it is intake of air, it is passing, and final is going it in as an 18 degrees Celsius, and the fresh air is being circulated here inside the ground floor as well as first floor, and the exhaust is being taken out from this area with the arrow, from the arrow, and it is taken outside. So if you understand these diagrams, so you can easily find out how we can try to calculate the CFM and all for exhaust as well as supply air. Now the different types of ventilation systems, you can see I am going to show you one by one here. This is one is fresh air systems for supplying the fresh air, exhaust systems to remove the air, toilet exhaust systems, so exhausting from the toilet, and room exhaust system. Suppose we also should need room exhaust system to recirculate the air, and kitchen exhaust system, office area fresh air system, office area exhaust system, corridor ventilation system. Suppose in an hospital or office areas there will be a corridor, so you want to provide a fresh air in the corridor. So in this kind of things we can need to design for the corridor ventilation systems also. And OT area ventilation systems, because operation theatre the air should be constantly recirculated and fresh air has to be brought in, and it should be in a filtered manner, and we are going to recirculate it, and we are going not recirculate, we are going to take in and take out, in and out, because it's an operation theatre. We should not recirculate there, because the bacteria will not be going out, it will be circulating inside only if we are trying to use an recirculation method. Treated fresh air systems. What is a treated fresh air systems? In a treated fresh air systems, so the air is being treated, the air is being treated means it is being cleared, it is cleared with the filters, and that is being supplied into the space, that is treated fresh air. Generally if it is not treated with the filters and all, it's a normal air only, so that is called TFA systems, that is treated fresh air systems. Factory ventilations. What is the importance in a factory ventilations? In a factory ventilations, we need to remove large amount of bad air, smoke, exhaust from inside the factory due to various processes. So that's why we need a factory ventilation systems where the fans, the big fans collect lot of fresh air and it will try to throw outside. So that is called factory ventilation system. Sometimes also we need to supply the fresh air inside the factory also. In this case we need to provide have a provision of ducting, so that we can supply the fresh air from outside into the factory. Coming to the tunnel ventilation systems, the tunnel you might be having or seen about the tunnel. It's a tunnel, it's a hole inside the hill areas where we will dig a very deep holes and try to keep some various safeguarding materials for the best storage levels. In those kind of things, the tunnel ventilation system is also very important, because for the peoples who are working inside the tunnel, there should be a fresh air and exhaust also for recirculation of air. In these cases we need the tunnel ventilation systems with the different kinds and different setups of fans. So tunnel ventilation system is also very important in this kind. Coming to automobile ventilation systems, in an automobile ventilation systems, it's a closed cabin. So how we need to provide fresh air from outside to inside without disturbing the temperature, present temperatures. How it is going to do, that is in automobile ventilation systems. In a similar case, railway tunnel systems also, the tunnel which is in the rail which is passing inside the tunnel, there should be some ventilation system for the maintenance people, as well as in case of breakdown and all, there should be some proper flow of air inside the train. Mine ventilation systems, in a mines where the people who are working, who have very less access to the fresh air, in these kind of things, the mines also should have some proper fan ventilation, so that the workers do not get affected because of the low level available ventilation systems. football stadiums and indoor ventilation stadiums. So football stadiums are outdoor stadiums. Sometimes we close the dome for giving the temperature. In those kind of things, we should supply fresh air and exhaust also. So stadiums are like shuttle, table tennis, and other kind of sports which are coming under the category of indoor ventilation systems. We should have the ventilation methodology for giving an perfect beneficial for the sports person who are always practicing or while doing their activities. So I have said that 8 changes per hour. So 8 changes per hour as per ASHRAE standard. Suppose it's a normal house, we should have 0.35 to 1 8 change per hour. Only one time you can replace inside a house. That's what it is saying. 0.3 to 1. So you can take maximum value as always, that is 1. In a hotel rooms under it is 1 to 2. 1 to 2. In office areas 2 to 3. Retail shops 2 to 3. Air changes per hour. So 3 times the total air will be replaced within the hour. That's what I mean. So restaurants and all has a lot of occupancies as well as kitchen, everything will be there. So that's why the replacement is 6 to 8 smoking persons, those kind of things. So coming to hospital areas, you can see the critical and intensive care areas. The total ACH is given as 6 air changes per hour. So within an hour, the air has to be replaced 6 times. So airborne infection isolation rooms also has 12 ACH. It's a higher, I think. You can see here. Examination room only 6. Guys, you try to understand and try to memorize these air changes per hour values when you are designing for a particular process area, maybe healthcare sector or a normal factory or another banks or financial institutions, any other things, or educational also. So you need to go through these particular tables and you need to submit or take the reference of these values. These all values are based on ASHRAE. See here, one more thing here. See, this is a table of minimum ventilation rates in a breathing zone. See, occupancy category they have given. These are also ASHRAE values. Auditorium seating area. So, cubic feet CFM per feet square. This much of value you have to take. People at outdoor rate. Okay. So like that in libraries, how much you can take? People outdoor air rate, CFM person, 5. Other libraries you can see 5. So CFM required depending upon the ventilations, the people outdoor air rate and area outdoor air rate. These are also ASHRAE values you can take while calculation. The exhaust rates. Exhaust rate for the auto repair rooms is 1.50 CFM per square feet. In case of a dark room, that is 1. In case of a log room, that is 0.50 CFM per square feet. So these are the minimum exhaust rates. I think you can try to have a look in the ASHRAE data book once you are trying to do the designing. Now coming to fans. What is a fan? A fan is some kind of an external device which is used to impart or push the air from one place to another place. It's a kind of equipment. Okay, so that's the definition I can say. So there are different types of fans here, because without a fan, air cannot be moved from one place to another place. So how much how much volume of fan air is required for selection of a fan? how to select a fan. These are very important, and now we will see important overviews of fans also. The fans are divided into two categories, that is, one is centrifugal fans, so another one is axial fans. So under the centrifugal fans you can see radial fans, forward curved fans and backward curved fans. So radial fans, they are also used for in industrial applications where they work as a workhorses because due to of high static pressure and to remove the contaminated air streams. So they are used for mainly factory areas where we need to throw out inside air to the outside. Forward curved fans, they are used in a clean environment and operates at a lower temperatures. They also just like move large volumes of air against the relative low pressures. The forward curved fans you can identify when the shaft is moving in a one direction, the curves of the blades also in same directions. So what I mean is the rotation of a fan and the curves inclined are both in a same wise. Coming to backward curved fans, backward curved inclined fans, whenever you can see that here the backward fan, when the shaft is rotating forward and curves will be in the backward side. So this has a maximum peak power consumption and drops at an very usable level of airflow energy when it is attained a maximum power or overloading. So this is the advantage of backward curve fans. So backward curve fans are also very good in usage of HVAC industries to take up large amount of air. And these backward curve fans are a little bit costlier because due to cost effects in HVAC industries, they are sometimes replaced with the other fans also. So mainly the backward curve fans are using air handling units for drawing large amount of airs and throwing with a large amount of airs. Coming to next one, that is the fan types, comes under the axial fan flow. So axial fans, the types are tube axial fan, vane axial fan and propeller fan. The tube axial fan, what are the tube axial fan? The tube axial fan, it is housed inside the cylindrical house in which the clearance of the blade and housing will be there, and mainly it's operated on the high pressure of 250 to 400 water column, and efficiency generally for fans it will be 65% to 70%. So guys, I will show you the fans types also, how they are have they will be there, and you try to understand what are the different types right now. Vane axial fan also similar like tube axial fans, but in a vane axial fans there will be guided vanes to streamline the air path or airflow. This is only the difference. The propeller fan, another category is propeller fan. It runs at a lower speed and have capability to take a large amount of air with high static pressures, whereas the propeller fans are mostly used in the factory industry to take lot of volume of air and throw air at large rates. See, you can see these images: tube axial fans, vane axial fan, propeller fan, and tube axial fan cross sectional, vane axial cross sectional, and propeller fans. These three fans are present. And coming to this one, these are forward curved fans, and these fans are also used in the AHU to draw a lot amount of air for supply. Another is paddle blade fans, forward curved fans, backward curved fans. You can see the impellers mainly. Fan loss, what are fan loss? Fan loss also are very important in deciding the selection of fan as well. So here Q1 by Q2 is equal to N1 by N2. N1 is number of RPM and N2 is number of RPM. Q1 is the volume of gas and volume of Q2 is volume of another gas, that is a gas or air, I can say. So you can see by varying the RPM by 10% decrease or increases the delivery by 10%. So by varying the RPM by 10% decrease, the air delivery increase by 10%. RPM we are trying to decrease by 10%. This air delivery is also increasing by 10%. So this is the formula Q1 by Q2 is equal to N1 by N2. So static pressure of 1 to that of static pressure 2 is equal to N1 by N2 whole square. So here also you can see from the graphs as well, these graphs as well, you don't if you are not saying, is going to miss something. So try to see here. Reducing the RPM by 10% decreases the static by 19%, and an increase in an RPM by 10% and increase in the static by 21%. So this is how it is working. Reducing the RPM by 10% decreases the power by 27%, and increase in the RPM by 10%, the increase in the power requirement by 33%. So we also have some of the method to find total pressure, velocity pressure and static pressure. So you can see here I am trying to zoom. So when you are going to connect a pitot to this air which is flowing through the tube, so one end is open and other end is directly connected to the vertical. So we are finding static pressure. So airflow is like this, but the connection is like this. This is the way to find the static pressure. To find the velocity pressure, the pipe mouth will be faced along the airflow, so that other end is also open. From that we can find the total pressure. To find velocity pressure, again it's the same thing, it is facing towards the air and vertically connecting to the pipe. This is called velocity pressure. You can see these are called pitot tubes. You can find the static by using these methods, that is static pressure, velocity pressure as well as total pressure. Fan loss I already told you. CFM2 by CFM1 is equal to N2 by N1 and SP2 by SP1. Most of the sound generation in air conditioning system is due to the fans. So your fan selection for the sound dB level also consideration is very important, because this sound only directly transfers to the duct through the duct system to the space. Fan performance can be used to correct the fan selection, operate and troubleshoot the tool procedures. It can be best understood by using seen the curved. Fan ratings also based on the testing of the fan based on the air movement and control associations. This is very important, you can remember. The performance curves enables an engineer to visualize the changes in the static pressure, brake horsepower and efficiencies very easily. So fan curves also, studying the fan curves also is very important. So each curve also represents the performance at a specific fan speed and air density. So it depends upon the fan performance characteristics, the performance of BHP, mechanical efficiency and static pressures can be found out. So how to find the fan and how to select the fan selection. The CFM required for building ventilation is equal to building cubic meter per air change. So see, this is a building dimensions 10, 7, fine, 12. The total HS required is 4. So this divided by 4, you will get the 22,500 CFM. So the fan selection 22,500 CFM should be used for heavy duct exhausting at 0.125 static. So generally you can take 0.1 default. If you don't know any uh, total bends of a duct and everything, you can directly defaultly takes the 0.125. So how to select the fan for a bathroom and all? See, the bathroom size is 5, 7 and 8. So the CFM will be 280, and if you want to change to 3 times, since it's a toilet, 3 times, that is 3 times AHU, the multiplying it by 280 into 3, 840, and it will be an hour. So to convert to CFM, that is 840 divided by 60, you can get an 14 CFM. So this fan will be very small since it's in 14 CFM, so which would be suffice or best for fixing to the toilet. So guys, I think you have understood about everything. So please try to uh, understand about these topics and all. So thank you for this one.